Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 4, Section 2, Triangle Congruence using SSS and SAS. So SSS is side, 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 and SAS is side, angle, side. So for this section, we're going to have a bunch of postulates, and then we'll actually have one theorem. So unlike parallel lines, which we had for each one of those, we had one postulate and a whole bunch of theorems. This one we're actually going to have lots of postulates and only one theorem at the end. Okay. So we've learned that we can prove two triangles are congruent by showing that all the corresponding sides are congruent, all the corresponding angles are congruent, and then we can use definition of congruent polygons. Well, in the next two sections, we're going to learn quicker ways to prove triangles are congruent. We don't actually have to show that all the sides are congruent, corresponding sides, and all the corresponding angles are congruent. The first one we have is called side, side, side. Okay, and you can abbreviate it SSS. This one says if the three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Okay, if we can show that the three sides are congruent, we don't have to show anything with angles. We know that the triangles are congruent. And if you had this one with the Euclid's Cafe, you should have seen that there's only one way you can draw the triangle. If I give you three sides, you start with one side and then you put the other two sides off of the angle, and they only meet in one spot, so you're only going to get one triangle. So for this one, we could say that triangle GHF is congruent to triangle, let's see, I started with G here, so I'll start with R here. Oh, actually I have to start with P, so PQR. Next one we have is called side, angle, side, and it is important the way you say it. The angle is between the sides, and when you do this proof, the angle has to be between the sides. So if two sides and the included angle, which means between, of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Okay, so here notice what we have. We have two sides, CB and DF are congruent. We also have two sides, CA and DE are congruent. And then the angle that is congruent is the angle that's between those two sides. So this one, if you had Euclid's Cafe, you also should have seen that there's only one triangle that you can get, because you start with a side, you do the next angle, you do the side, and there's only one way to connect the third side so that it meets. And so you can't get multiple triangles. So for this one, we could say that triangle CBA is congruent to triangle DFE. So here in this problem, we're given that RS is congruent to TK. What other information do you need to prove that the triangles are congruent by side, angle, side? So side, angle, side would be two sides and then the angle that's between those two sides. This is one of the first times that we're going to use a reflexive property. And here's what I can say. I can say that if you take a look at the two triangles, they touch each other and they share a side, and that side is SK. And so if I was doing a proof for this one, I could say that SK was congruent to SK, and I can use reflexive. So there's actually one of my givens. I'm given that two sides are congruent. I'm also given that the second side is actually reflexive. It's itself, so it's congruent to itself. And so the only thing I would need the angles that would be between those two sides. So somewhere I would need to be given that angle RSK is congruent to angle TKS. And that might be just one of the givens, or they might give me enough information that I could get there, but that would need to be one of my givens in order to do this proof. Okay. That's it for today's notes. Thank you for watching. Have a great day. Take care.